All right, welcome to part B, doing part E of the unit 2 ratio and rate test. We are in the spacious breakout room. Mr. Moore is filming once again. My human calculator in my back pocket, ready to fix mistakes along the way. So let's finish off with these final 4 word problems. Again, this was an answer 3 of the following. Please follow the instructions. They are there right in front of you, bolded and asterisized. All right, so we have this first one here. It's that typical who had the better drink. So for the Terry Fox run, each house is responsible for making punch. Mr. Meakin always says the Morrison punch is better than the McClintock punch because it's stronger. Is he right? So first off, how are we determining strength? Well, we're determining strength based on the amount of cans of concentrate compared to the total amount of water. So if you have more concentrate, then your juice will be in essence stronger. So what we're doing here is comparing 2 ratios. So we're comparing the ratio of 4 to 5 and the ratio of 2 to 3. I can't compare these ratios as they are now though because they have different second or first terms. We usually want to go with the second term. It seems to be the easier one to do. It's just like making the denominator the same in fractions. So we're gonna want to make our denominators or our second terms the same. So first off, let's label everything here. So this is Mo, this is McClintock, this is concentrate, and this is water, and this is concentrate and water. So in order to make these second terms the same, I simply just multiply them against each other. So if I multiply 5 by 3 and 3 by 5, my second terms are both going to end up at 15. So now I've made an equivalent second term for each of them to the first term by multiplying them by the flipped multiples on either side. So now the water amount is the same in each recipe. Remember, whatever I do to the second term, I need to do to the first term, and vice versa. So if I take 5 times 2, and I take 3 times 4, now I have 12 cans concentrate to 15 cans water, and 10 cans concentrate to 15 cans water in McClintock. Obviously, we knew the answer the whole time was going to be that Morrison's was stronger because we are a far superior house. So I'm going to say that therefore, the Morrison punch is stronger with 2 more parts concentrate. All right, this one here. So you can solve this problem in 2 ways. We're going to solve it the simple way though. So I have a basketball court that's 15 meters wide by 30 meters long in real life. So I'm just going to draw out my basketball court. So I'm going to use 30 meters as my long measurement on the bottom and 15 meters on the side. So it says a scale plan of it is drawn with a width of 20 centimeters. So this is important that you put the measurements, that you line them up the same. So we said that it's 15 meters wide. So if 15 is this side measurement of the basketball court, I'm going to say this one is 20 centimeters. Now what we don't know is what is the length of the basketball court in the scale drawing. So remember, a scale plan or a scale drawing or a scale model, it's proportional. It means that everything on this there's a proportional relationship between them. So if you were to multiply this by a certain amount, it would be the exact dimensions of this. That being said, look for relationships in your length and your width. So if my length and width relationship is, in this case, 2 times greater, guess what? It's going to be the same in your plan. Think about that Bill Nye video we watched about the Hollywood sign. Bill was able to say that the height to length ratio was 8 to 1, and he was able to apply that from the model of the Hollywood sign to the real life version of the big Hollywood sign. There's a proportional relationship here. So all we need to do to find my length of my scale drawing is just multiply by 2 like I would do on my real life version. So my math here is 20 centimeters times 2 equals 40 centimeters. That is it. Therefore, the length is 40 centimeters. Don't overthink it. 2 last questions. So we have Miss Taylor. In Miss Taylor's garden, she has 121 vegetables growing. In her garden, she has cucumbers and tomatoes. That's it. So the relationship of cucumbers to tomatoes is 8:3. So first thing we want to do is put everything down that we know. So we have a ratio of 8:3. This is cucumbers to tomatoes. Okay. My total number of vegetables in the garden, if this was an 8:3 ratio and there was only 8 cucumbers and 3 tomatoes, would be 11 total vegetables. But I know that we said that the total is 121 vegetables. So I need to figure out what my parts would be to give me a whole of 121. Well, look at this mathematical relationship. If I multiply 11 times 11, I get to 121. If you do that to the whole, you have to do that to the parts in your ratio as well. So I'm simply just multiplying this by 11, the second term and the first term times 11, which ends up with 88 to 33. And if I add 88 and 33, guess what? I get 121 vegetables in total. Therefore, she has 88 cucumbers in her garden. And finally, our last one here, we're looking at comparing two rates, but we want to get them down to unit rates. We're not going to say a car is traveling a certain amount of kilometers per minute. We want to change this to hours. So again, same with the original example where we said 120 minutes is equal to 2 hours. Well, guess what? That's double 120 minutes. So if 120 minutes was 2 hours, then 240 minutes has to be 4 hours. Okay, so now I can say that I have the truck and I have the car. The truck is traveling 272 kilometers per 4 hours. The car is traveling 630 kilometers per 9 hours. What I want to do is reduce these to unit rates. So just like we did originally, divide that by 9. That gets me down to 1 hour. Whatever I do to the second term, I need to do to the first term. 63 divided by 9 is 7, so 630 divided by 9 has to be 70. On the flip side, Mr. Moore, I know you've been thinking about calculating this since you saw it. So if I divide this by 4, I get down to 1 hour. And if I divide 272 by 4,
I think it's 68.
it gets to 68. Mr. Moore is legitimately a human calculator. So we have 68 kilometers per hour. So then the average speed, my car was traveling 2 kilometers per hour faster with their average speed to travel those distances in those times. So therefore, the car is 2 kilometers per hour faster. Pencil drop.